Welcome back, guys. We're doing our second official lesson here in Algebra 1, and we're talking about the order of operations, which hopefully I'll just be kind of refreshing your memory, brushing up some skills. You've seen this before. I hope you're a little familiar with it. Your goal is to be able to use the order of operations to simplify expressions. So we're not looking at stuff with equal signs, just looking at expressions. Simplify, you're just making them look nicer, working out what you can, making it look better. So the order of operations is totally crucial in math, and what it does is it provides us with a rule for what order to solve a math problem in. Okay, if I gave you all number 4 down here, and I said, solve this, like figure this out, what does this equal? Well, if we did not have the order of operations, it'd be a free-for-all, and we'd probably come up with like 12 different answers. Okay, there'd just be no set steps to follow to work something like this out. Okay, so order of operations, we need it. You've probably heard the acronym before, and I'll just kind of write it off to the side here. It's PEMDAS, or maybe you like to remember it. This is how I do. Please excuse my dear Aunt Sally. Okay, those are the letters that kind of help you remember what to do first in a math problem. So I'm going to arrange those letters in this little like hopscotch looking thing, if you will. And we'll remind ourselves what every letter stands for. So the P is parentheses. We all know what parentheses look like. If you see those, you take care of what's inside the parentheses first. Then you deal with the exponents. So an exponent is something like 3 squared. It's got a little power there, or maybe like 4 to the 5th. Be careful and mindful that this does not mean 3 times 2. Okay, this means whatever the power is, the squared, that's how many times you multiply the base number by itself. So it's actually 3 times 3, which is 9. 4 to the 5th would be 4 times itself 5 times. Okay, then we've got multiplication and division, the M and the D. And those are situated next to each other, and they're there for a reason. Same thing with the last 2 operations, adding and subtracting. Those are next to each other. So I'm going to kind of like group those guys together. There's a reason they sit next to each other and not just alone. If you have multiplying and dividing in the same problem, you don't always do multiplication first just because it comes first in PEMDAS. You have to think of those operations together, and you have to read the problem from left to right. So I'm going to make that note. And whichever one you see first as you're reading the problem like a sentence, that's what you take care of first. The same thing goes with addition and subtraction. You have to think of them together, and whichever one you see first as you're reading from left to right, that's what you do first. So this first example here shows us exactly that. I have multiplication and division. If I multiply first, because some people will say, oh, well, M comes first, so I'm going to do that first. Well, those people would do 2 times 4, which is 8, 8 divided by 8, and they would get 1. But if you do the division first, so you say, oh, well, 8 divided by 2 is 4, and then 4 times 4, that's 16. Those answers are so far off, so prime example why we need the order of operations, they bring us all together and get us the same answer. And the correct answer is doing multiplication together, so reading it from left to right. You see the division problem first as you read it, so that's what you have to do first. So the correct answer is 16. All right, let's try a few examples together. So number 1, parentheses comes first, and I do see that here, so 14 plus 3, I'm going to take care of that first. And then I'm going to bring everything else down. Okay, then I've got exponents, which I do have in this problem, 6 squared. 6 times 6 is 36. Now I have addition and subtraction, and my advice is to copy everything that you haven't dealt with yet down so you don't forget anything. When I have addition and subtraction, I think of them together, read it from left to right. I see the addition problem first, so that's what I'm going to do first, and that's going to give me 68. Then I can subtract, and I get 51. Example 2, oh, this is a fun one, fractions, everyone's favorite. Before you freak out about the fractions, you've got addition and division. So obviously I needed to divide before I'm going to add. So I'm going to do this division problem off to the side here because it might take a little bit of work. Make 2 a fraction. This will make it look nicer. Think back to middle school. Remember, keep, change, flip. If you're dividing fractions, you can rewrite this as 3/5, so keep the first fraction, change it to multiplication, flip the second fraction. Then you just multiply across on this problem. So 3 times 1 is 3, 5 times 2 is 10. So this is just 3/10. Bring down the 1/4 and the plus sign. Ooh, we're really testing your skills here. Now when I'm adding fractions, remember I need a common denominator. And I'm going to go for 40 just because it requires the least amount of thought. So I'm going to multiply the first fraction by 10, the second one by 4. My new problem is 10 over 40 plus 12 over 40. Add the numerators, and that's 22 over 40, which can be reduced, so you should. I notice I can divide both of those by 2, so that gives me 11 over 20. Ooh, that is a good problem. All right, I'll take it easy on you. I want you guys to try number 3. Again, you will not get full credit unless you try this problem. So I'm not looking necessarily for right or wrong answers. Obviously, I would love for you to get it right, but I'm mostly concerned that you're putting effort in and you're following along with the notes. Number 4 I'll do. This one looks super fun. Notice that you've got these brackets here. They'll use those if there's like multiple sets of parentheses. So those just mean like bigger parentheses. Really it just means take care of the 5/3 last. So inside the brackets, I see 2 sets of parentheses. I'm going to deal with those first. So 2 times 9 is 18. 15 divided by 3 is 5. And I've got the exponent there, which I need to do next. So 5/3, then 18 minus, let's see, 5 squared is 5 times 5, 25. Still inside those brackets, 18 minus 25 is -7. Okay, so this just means multiplying if you've got parentheses sitting next to a number. So let's kind of carry this over. I've got to do 5/3 times -7, so make that a fraction. Multiply across, -35 over 3. Or you can convert that to a mixed number, since I'm looking at an improper fraction. 3 goes into 35. Let's see, 3 times 11 is 33, so it's 11 times. Make it negative. To get to 35, I need 2 more, so there's 2 left over. So it would be -11 2/3. Guys, I've said it in class before, but I'm going to say it again. If you need help with some of this fraction stuff, you need to ask me, okay? It's all review, but that doesn't mean I'm like assuming you remember everything. You've got time in class, you need to ask me because a lot of it is covered on the first unit exam in a couple weeks. Okay, on the back, sometimes you'll be asked to evaluate an expression. That sounds really fancy, but that just means that we're replacing a variable, some letter, with a number. Then you're going to do exactly what we did on the front. Okay, I'm going to star this because this is huge in this class. If you're not in this habit, it's a great habit to get into to use parentheses when you're plugging a number in for a variable. Okay, for example, And I'm going to have you guys, I'm going to circle them, both of them. I'm going to have you guys do these two problems. So let me start off with number 2. You can pause it and do this one first, test yourself. But if you want to watch me do example 2 and then go back and do 1, that's cool too. But here's what I'm saying. So they say evaluate the expression when x equals 5 and y equals negative 2. All you're doing is plugging this 5 in where x is and negative 2 where y is. You just need to use parentheses when you replace x with what it equals, which is 5. I know y is negative 2, so I'm going to stick that next to the 2 in the problem. Now I'm just looking at the order of operations. Don't get thrown off by the parentheses. There's nothing inside the parentheses but a 5, so I can't do anything with the parentheses. I really just have multiplication right here. That's all this means. So I've got 2 multiplication problems and a subtraction problem. So I'm going to multiply first. Now I'm going to make that 5 over 1, so I can just do 2 times 5 is 10, over 3 times 1, which is 3, minus, now I'm going to think of this as negative 2 times negative 2, which would be a positive 4. So that's okay to do, just say plus 4. Got to add fractions, so I know I need a common denominator, so I just got to get a 3 on this second fraction here. So this is really just the problem 10 thirds plus 12 thirds, which would be 22 thirds, or that's the same thing as 7 and 1/3. 3 goes into 22 7 times to make 21, and there's 1 left over. Your number 1 is much easier than number 2 that I just did. So see if you can get that one. Number 3 here, I'm going to go ahead and do. So same thing, I'm going to plug in 5 for x, and I'm going to use parentheses. I'm going to keep the parentheses that are already in the problem also, so it's kind of a lot going on. So I'm going to work out inside this group of parentheses and this group of parentheses. That just means multiply. So I've got 2 times 5, that's 10. Do that before the subtraction. I'm going to multiply these guys. Half times negative 2 is negative 1. Then I'm going to go ahead and subtract here, and I get 3. Negative 1 plus 3 is 2. So it's really just 3 times 2, which is 6. Okay, last kind of example here, and I want you to try 4, like I said. But John claims that x plus y squared is the same thing as x squared plus y squared. Is John correct? So let's find out. I mean, let's plug in our 5 and our negative 2 and see what we get. We're probably better than John. No offense to any Johns in the class. I'm going to use my parentheses. Let's see what I get on the left-hand side. Well, I know I'm going to do the order of operations, which tell me to work out the parentheses first. So it's really just 5 plus negative 2, which is 3. I'm really just looking at 3 squared, which I know is 9. Let's see if I get 9 on the other side. Well, the other side, the way it looks, I don't really have parentheses, because again, there's just a 5 in the parentheses, and negative 2. You can't do anything inside the parentheses. So I have exponents. Squared means times itself, so 5 times 5, and this is negative 2 times negative 2. So that gets me 25 plus positive 4, or 29. And those are not the same. So no. John is not correct. Evidence, math, does not lie. Proves it all right there. Parentheses make all the difference, people, as you can see. And this example shows how evaluating expressions can help us check our work. Okay, so that's kind of an example of that. At the bottom, this is kind of just food for thought. And it's, again, something that's really review from middle school that you will see this year. It's important to note. So we're just going to kind of like point it out right now. Now, this symbol, so I'm going to put an X inside of the symbol. It's not parentheses. They're just straight up and down bars. These are absolute value bars. and hopefully you are familiar with these. But absolute value just represents a certain number's distance from 0. Okay, so if I think about the number line here, and I'm asked, how far is -4 from 0? Well, there's 0, and it's, let's see, 1, 2, 3, 4 units from 0. So this is how we represent that with our absolute value bars. Absolute value means how far is it from 0. So if I put those bars around a number, you're just going to tell me, oh, that's 4 units away from 0. That equals 4. Same thing if I'm talking about like 3. How far is 3 from 0? Well, that's 3 slots from 0. So, oh, this got cut off. We represent that by saying, yay, the absolute value of 3 is 3. Okay, so really what I want to point out here is the absolute value bars they make a number positive. And the reason that they do this is because you can't have negative distance. If you're measuring how far something is from 0, it doesn't make sense to say, oh, it's -2 units. No, distance is always positive. So absolute value is always positive. If you see the bars, you just make a number positive. All right, and that is lesson 2.